Okay, chapter 4, lesson 5, adding and subtracting mixed numbers. First thing I have to ask is what's a mixed number? What's a mixed number? Owen?
Like 1605.
That's an improper fraction. Yeah, sometimes improper fractions and mixed numbers get confusing. Now it's a mixed number.
Like 1 and 1/5.
Yes, 1 and a fifth. So it's having a whole number and a fraction put together. We're going to talk about how to add and subtract them today. Matt?
Didn't we do some of this on our worksheet?
You maybe did. You maybe turned fractions into mixed numbers, yes, but we're actually going to add mixed numbers together today.
Like there's like 1 and 1/4 minus like 1/3.
I think it was 1 minus 3/4. So kind of, but that would have been a whole number minus a fraction. That was technically not a mixed number. Your answer would have been a mixed number, though. I told the other class I was going to show them 2 ways to do it. They decided they only wanted to see the first way, the easiest way. Okay? Yep, that's fine. And then we can decide if we want to go to the second way. It's up to you. I was going to review a little bit, but I want to save my time. So we're going to go right to me showing you what to do. Okay? So this is the first way I showed the 7th graders in the other class how to add and subtract. So first thing you're going to do is I put it like a list together for you. So the first thing you do is you're going to focus on the fraction part. And then the second part is you're going to focus on the whole numbers. So you're going to pretty much split it in half and work with one side and then the other side. Now, since you're getting older, a lot of times your problems are written this way now, not up and down. Like you're going to see that all the time in your math books. A lot of time it's written from side to side instead of up and down. So I suggest, to make it easier, you actually write them up and down, like this. To me, it's easier to see. It's easier to put together what you're actually adding together. Okay, so to me, it's easier to see it and get your mind straight when you see it like this. Now, what I would do is I would put a line down the middle, separating my fractions from my whole numbers. The reason I did that is so I can say, oh, I'm going to add this side together first. Then I'm going to go and add this side together first. Okay? So let's focus on this side first because that's my focus on the fractions part. I have 1/4 plus 3/8. What do I have to have? Yep? Common denominator, what can I use? 8. Okay, this one's already 8, but I got to change this one. How do I get from 4 to 8? Multiply by 2. So 1 times 2 is 2. So I'm not working with this one anymore. Now I'm going to add together just like what I did the last 2 days. I'm going to add together. So this side would add to 5/8. And then I'm putting together this side, 7 and 5/8. I don't know what you learned last year. Yep.
I like it that way.
You'd like it like this? Yep, that's fine. You do whatever you want to do. You do whatever you want to do. It does not matter to me. I tend to find myself writing it like this for myself. But if you want to do it that way, you're more than welcome. Okay? You don't have to do everything my way. Okay? All right, let's try another one. Let's do another one. 7 and 5th. And if you want to write it the long way too, I just have them written here like how I like to see them. So if you want to write them the other way, more than welcome. 7 and 1/5, 3 and 4/10. Matt?
10.
Yep. Or you know what? Some of the other class said, well, can I reduce this to make it 5? Sure, you could if you wanted to, but I'm not a person that can see reducing right away. I'm a person that looks at the denominators, but if you saw that you could reduce this to 5ths, you can do that too. But yeah, I would have went to 10. That's what you're telling me? Like this?
I'm saying the answer.
Oh, I'm not ready yet. I'm not ready yet. So 2 plus 4 is 6/10. 7 plus 3 is 10.
You can reduce that.
I can reduce by what? 2? Yep. So it'd be 3/5. So it'd be 10 and 3/5. Would be my answer. All right, let's do another one like this. Actually, I'm going to add a new page. Let's try this. Let's do 7 and 5/6 plus 3 and 2/12. gonna try by yourself? I think you already are. Oh, really? Well, that was nice. This would have been 12. This would have been 10. So, okay, this is what it looked like then. Okay, now what? Now what, though, Matt?
It's 11.
Okay, so because this turns into what? 1. I'm going to put those together. I get 11. Good job. Good job. Yep.
That was very easy.
That was easy. Dang. All right, let's try another one then. Ah! I always make them too easy for you guys. 1. And let's do 3/4 plus 2 and 1/2. Just like that. Try that one. Not done yet. Just wait. What's the matter?
No, I'm wondering.
Do I get a problem in a problem? What's the matter? What do you mean? Oh, it's 2.5. I crossed it out. I crossed it out. I just crossed it out so I see what I just need to use. I got a problem in my problem, literally. What's the problem I have in this problem? No. I have an improper fraction there. I cannot have an improper fraction here. So what would I do to make it so my answer is still correct, Mason? What's that? Well, let's change this to a mixed number. Let's not worry about this. What's that as a mixed number? 1 1/4. Now, what am I going to do? Take these two things and add them together. Yep. So if you have an improper fraction, change that guy to a mixed number, and then you can just put these, combine them to, Matt.
Can we do a 3-number fraction?
No, not today. Not today. I do need to go to subtraction, though. The other way that I was teaching the 7th graders how to do it was to change it into an improper fraction. That's not my favorite, because then you get huge numbers. Like, this is my favorite way to do this. What did you learn last year? A fraction, so you didn't worry. Did you learn this?
She taught us to take one away from the whole number and add whatever the denominator was.
Oh, I'm just talking about like doing this in general. Like, what was the method that they taught, that she taught? Was it like what I taught you, or was it make it into an improper fraction and then doing it? Like, same thing? All right, let's go to some subtraction now. And I'm just going to go, let's do 6 and 5/8 minus 2 and 1/4. Okay, same thing. What's going to happen? You're going to change your denominators. Okay, subtract this time. This would be 3/8. This would be 4. Same thing, you're just going to subtract. Now, I think what Nolan was talking about, he was talking about what if you needed to borrow, like you didn't have enough fraction to give away, like when you're subtracting. So if I do a problem like this, let's see if I can think of one. 7 and 1/7 minus, I'm always using 7. I feel like 7 is always the number I'm using. 1 and 5/14. So change my denominator. This is 14. This would be 2. Okay. Now, do you understand how I can't take 2 minus 5? So many people will say, well, I can take 5 minus 2. It doesn't matter. No, subtraction actually matters, and the way you do it in order actually matters. So I can't take 2 minus 5. So, Matt, what do I have to do?
You have to change the 7 to a 6, and then it'll become 60.
Okay, so let's back up. I need to take some from here. We're going to make this a 6. When I take that 1, that turns into some fraction pieces that I can put over here. It turns into 14 over 14. It turns into whatever the denominator I have is there. Then I add them together. 14 plus 2 would be 16 over 14. So I basically took one from here, split it into some fraction pieces, and putting it over there. So now I can subtract. Now I have 11 over 14. 6 minus 1, 5. Okay? So does everybody understand how I figure out what this is over here? Like, that's the biggest thing. You have to know what number does that turn into? How do I know what? And one of the other kids in the other class said, well, if you just add, what was it, these two together, it'll give you, if you add these two together, it'll give you that top number. So that was a way too that I've never really thought about before. So last thing before we go, because we only got a few minutes left, is if I have subtraction and I don't have a fraction with it. So like 8 minus 2 and a fifth, how can I subtract this, Zaylee? Yes, you're right. This turns into 7, and this turns into, that one you took turns into 5 over 5. Now I can subtract 4 fifths, 7, 6, 5. Yep. So if you're missing it, you got to make sure you turn it into the pieces. Question?
How come you never let me answer the problems and just do them on the whiteboard?
I don't know, because I'm going fast today because we don't have a lot of time. Yes? Oh, the other way? You want to see the other way? Okay, the other way would be like, let's say I have this. I'm going to do an addition problem, okay? Let's do 2 and 1/2 plus 6 and 1/3. Let's say that's my problem. Well, another way to do it, if you want another way, change these into improper fractions. 2 times 2 is 4, plus 5, this would be 5 over 2. 16, what is it, 18, 19, 19 over 3. Okay, then I still have to have the same denominator. So I could use 6. This is times 2. This would be times 2. What is that? 38. Times 3 times 3. See how it's a lot longer? Yeah, it's a lot longer. So if you stick, the other way is way easier. Way easier. Yep, I agree. So I would stick with however you want to put it, whether you put it horizontal, up and down, it does not matter to me. Just make sure if you have different denominators, you're changing them. Yes?